This video is just a couple of comments on the previous rules. The first is a note on the third one from the previous video. The square root of a squared equals absolute value of a. You won't actually use this. It is definitely true, but there's a little kind of workaround people do just to avoid, because students tend to get confused by this. So just to avoid that for now and kind of push it off until you get to, say, calculus or something, if you plan to go that far with math, they'll say something like, assume all quantities are positive so that the square root of a squared equals a. Right, you don't need the absolute values if a is already positive. And so then that way you don't need the absolute value and you don't have to try to figure out when do I need it and when don't I need it, which gets a little bit confusing and it's just a little bit beyond the level of the course is all. So this is a common workaround for that. Okay, so common error that people make. Nth root of a plus b is not equal to the nth root of a plus the nth root of b. You can't distribute nth roots like you can multiplication. It doesn't work that way. That's a special property of multiplication, the distributive property. It does not work here, okay? It works if a is times b, but not plus. The rules for addition are not as nice as the rules for multiplication. So multiplication and division, nicer rules. Addition and subtraction, there's a lot of things that you can't simplify with addition and subtraction. Unless a or b is 0. Obviously, if one a or b is not even there, then this works. Basically. So for example, square root of 1 plus 1 is not equal to the square root of 1 plus square root of 1. Because the square root of 1 plus the square root of 1 equals 1 plus 1, which is 2. And the square root of 1 plus 1 is the square root of 2. The square root of 2 is not equal to 2, because 2 times 2 doesn't equal 2. Okay?